Hello everyone, in this video I'm going to talk about extra practice 1 in tutorial 1. So if you look at this question, we need to prove that for all real numbers x, y, z, this whole long inequality holds. If you just have a look at this inequality, it's really complicated and you might have no idea where to even start. So our first step is that we'll do some rough work and see if we can get to something that we are familiar with. So our first step is that I'm gonna expand this part and see if I can simplify it even more. So let's do that. 4x squared plus 6y plus 5y squared plus z squared is greater than or equal to 18y minus 4y squared plus 4x plus 2z minus 20. Okay, so our next step is to simplify it even more. So I'm gonna move the signatures, collect the signatures. So I'm gonna move this term to the other side. I'm gonna move this term to the other side as well. Okay, and let's see what happens. So this will give us 4x squared plus 6y minus 18y, so that's gonna give me minus 12y, plus 5y squared plus 4y squared is gonna give me 9y squared, okay, plus that square, and then I'm just gonna move the rest of the term to this side as well. That's minus 4x minus 2z plus 20, that's greater than or equal to 0. So for now, this is what I can do just to simplify it. Alright? Okay, so in order to get to something that we consider as a basic fact, or something we know like AGM, triangle inequality, I can see that, well, I have 3 different terms that have square in there. The first one is 4x squared, and then we have 9y squared, and we have a z squared. Also, not just that, we have, okay, just hold on a second, let me use different color. So we have this term, and we have this term. Also, you can see that we have other terms that has only x, y, or z only. Okay, so let's see. So z squared is paired up with minus 2z. 4x squared is paired up of minus 2x. And 9y squared is paired up with minus 12y. And then we have a constant left. Okay, so just by looking at this, I have some idea. So probably I can use complete the square. Okay, I'm telling you the reason why I'm choosing complete the square, because, well, we have, for complete the square, you can have something like this, which is greater than or equal to 0. Well, if you open this up, we have xy plus y squared is greater than or equal to 0. So right now we have this, and we have this. We have this as well, because if we write 20 as something plus something plus something, I don't know what those are yet. If you write them as like 3 numbers, and then we have this as well. So probably our idea is complete the square. Now, how do we complete the square? So we need to observe this, okay? So first of all, let me group them together. We have 4x squared, which can be written as 2x whole thing square, minus, well, we know complete the square, there is a 2xy term, so I'm gonna write 4x be 2 times 2x. Okay, now if you look at this, to complete the square, I need one more term, which is 1, or 1 square, right? So if you group them together, well, we have a complete square already. The next one is for y, so this plus 9y squared can be written as 3y, the whole thing square, minus, again, I'm gonna write 12y to be 2 times 6y, so 2 times 6 can be written as 3 times 2, okay, y. Why do I write it in this way? The reason is that I know I have a 3 here, okay? So this is my, let's say, this is my a squared minus 2ab plus b squared. So this is my a squared, alright? So I know that the coefficient is 3. So that's why I wrote it as like 3 times 2 here. Now, just by looking at this term, you should be able to figure out what's the term that's left. So we have 2 times 3 times 2, so this here should be 2 squared. Alright, then the last one is plus, so let's group them together. Last one will be z squared minus 2z, which is simple, 2z, 2 times z. So the last one will be 1 squared. And they are in one group. Now I have 20 left. 20, I distribute 20 into 1 plus 2 squared, which is 4. So 1 plus 4 plus 1, that's 6 already, so I only have 14 left, okay? And this whole thing will be greater than or equal to 0. Now, you can write each of the group into the complete square. So this will give us 2x minus 1 square plus 3y minus 2 square plus z minus 1 square plus 14, which is greater than or equal to 0. Okay? Now, once you get to here, what can you see? I can tell that, well, this step, it is a true statement already. Why is that? Well, we know this part is greater than or equal to 0. We know this part is greater than or equal to 0. And we know this part is greater than or equal to 0. And this is a positive number. So if you add them together, the whole thing is going to be greater than or equal to 0. Okay, so my rough work here is done already. Now, to write a formal proof, you just need to copy from the end back to the beginning. So, I'm too lazy to copy it down, so I'm just gonna add double-headed arrow everywhere, okay? And that is the end of my proof. I'm gonna delete rough here because this is my proof already. This is my formal proof, so I'm just gonna add proof. So there are two ways to make your rough work a formal proof. One way is copy backwards, okay? So this is your first step, second step, third step, and then fourth step. So that's one way. The other way is do what I'm doing here right now. You use this if and only if right here, okay? The reason is that if you use if and only if here, that means each of your steps is reversible. What do I mean by reversible? Which means it can go both directions. So going this way, the proof works, and going that way, it works as well. Okay, that is why this is my formal proof. Notice that you can not use if and only if everywhere in your proof. When you use it, you have to make sure each of your steps is actually reversible. It can actually go back. Alright?